Hello, science explorers! Ever wondered what makes up everything? It's a universe of tiny particles. Some, like protons, neutrons, and electrons, are familiar building blocks. But the particle world is a zoo, and some of its residents are truly strange. When physicists call a particle weird, it means it behaves in ways that challenge our theories. These oddballs stretch our understanding and excite scientists everywhere. Today, we'll meet three of the weirdest: the Muon, a heavy electron; Tachyons, faster-than-light maybes; and Axions, ghostly dark matter candidates. Each has its own wild story. Ready to explore these cosmic curiosities? Buckle up! We're about to journey into the subatomic realm, a place of mind-boggling wonders. Don't worry, we'll break it all down simply. Physics can be a wild ride, and these weird particles are the most thrilling sights to see. First up, the muon. Imagine an electron that's been hitting the gym, same negative charge, but about 200 times heavier. It's like comparing a house cat to a lion. Muons were discovered in 1936 by Carl Anderson and Seth Nettermeyer while studying cosmic rays. Their discovery was a total surprise. Physicist Isidore Rabi famously asked, "Who ordered that?" Muons are fundamental particles, not made of anything smaller, and belong to the lepton family, just like electrons. But here's their secret. Muons are unstable and live only about 2.2 microseconds. That's 2/millionths of a second blink and they're gone. In the fast world of particle physics, that's enough time for muons to do amazing things. Their heaviness and quick decay make them both weird and useful. They're not just heavy electrons, they're unique players in the subatomic world. So what can these heavy cousins actually do? Let's find out how muons are more than just cosmic oddities. Their properties make them valuable tools for science. Muons help us see the universe in ways electrons can't. They're fleeting, but their impact is lasting. From cosmic rays to cutting-edge experiments, muons keep surprising us. Let's dive into their real-world superpowers. Get ready for some particle detective work. Muons are everywhere. They're created when cosmic rays smash into Earth's atmosphere, showering us with billions every minute. About 1 muon passes through your thumbnail every second, silent, invisible, but always there. What makes muons special is their ability to penetrate hundreds of meters of rock or water. This superpower lets scientists use muons for muon tomography, like an X-ray for giant objects. One famous use exploring the Great Pyramid of Giza. Scientists placed muon detectors and found a hidden chamber, untouched for thousands of years. Muons also help study volcanoes, revealing their inner structure and helping predict eruptions. They're used to inspect large industrial structures and search for hidden tunnels. These short-lived particles from space are practical detectives, revealing secrets deep inside massive objects. Muons, though fleeting, are powerful tools for discovery. They turn cosmic leftovers into scientific gold. From ancient mysteries to modern safety, muons are on the case. Who knew space particles could be so helpful? Their journey doesn't end here. Muons have even more surprises in store. Let's see how they're shaking up the world of physics. The adventure continues. Muons have another trick up their sleeve: their behavior in magnetic fields. Like electrons, muons act like tiny spinning magnets. When placed in a magnetic field, they wobble a motion called precession. The standard model predicts exactly how fast this wobble should be, but experiments like the Muon G2 at Fermilab found the muon wobbles just a bit faster than predicted. This tiny mismatch is a big deal. It hints that our recipe book for physics might be missing an ingredient. Maybe there are undiscovered particles or forces influencing muons. This anomaly is a tantalizing clue, pointing toward new physics beyond what we know. It's like baking a cake with a perfect recipe, but it always tastes a little different. Scientists are excited this could open the door to a whole new realm of discovery. Muons, with their subtle surprises, keep challenging our understanding. They remind us that even well-known particles can hold deep mysteries. The search for answers continues, and the stakes are high. Will muons lead us to the next big breakthrough? Only time and more experiments will tell. For now, muons remain one of physics' most intriguing puzzles. Stay tuned for what they reveal next. Now let's shift from the puzzling muon to the mind-bending tachyon. Tachyons are theoretical particles that would always travel faster than light. Einstein's theory says nothing with ordinary mass can reach light speed. It would take infinite energy. So how do tachyons fit in? The trick is their imaginary mass. Not make-believe, but a mathematical term involving the square root of -1. This property means tachyons, if they exist, would always be faster than light. Think of the speed of light as a cosmic barrier. Normal particles can't cross it, but tachyons would live entirely on the other side. For tachyons, slowing down to light speed would take infinite energy, the opposite of our experience. It's a bizarre concept, flipping our understanding of motion. Tachyons challenge the very limits of physics. They're a wild idea, but they push us to think deeper about the universe. Even if they're just mathematical curiosities, tachyons expand our imagination. They remind us that physics is full of surprises. Could something really go faster than light? For now, tachyons remain a fascinating what if. The universe is stranger than we think. Tachyons' imaginary mass leads to even stranger consequences. If a tachyon loses energy, it speeds up, totally backward from normal particles. This upside-down behavior makes them fascinating, but also problematic. The biggest issue? Causality. The rule that causes come before effects. If tachyons could send signals, it might be possible to send messages into the past, creating paradoxes. Imagine getting a reply before you send a message. This tachyon paradox could break the logic of the universe. Most physicists think if tachyons exist, they can't be used to send information, avoiding these paradoxes. Sometimes tachyons pop up in theories as a sign of instability, a warning light for physicists. Even if real tachyons don't exist, the idea helps refine our understanding of physics. They force us to test the boundaries of our theories. Tachyons are a reminder. Not every wild idea is real, but every wild idea teaches us something. They keep science honest and creative. The universe is full of puzzles, and tachyons are one of the strangest. Onward to our next cosmic mystery. Our final weird particle is the axion, another hypothetical, but with a real purpose. Axions were proposed to solve the strong CP problem, a puzzle about why the strong nuclear force is so symmetrical. The strong force is the glue holding atomic nuclei together. Theories suggest it should violate a symmetry called CP, but experiments show it barely does. Why is the strong force so well behaved? In 1977, physicists Pesce and Quinn proposed a new symmetry to explain this. Their theory predicted a new particle, the axion. If axions exist, they'd naturally solve the strong CP problem. Axions would make the strong force's unexpected symmetry make sense. But axions aren't just theoretical fixes, they could be everywhere. Their existence would tidy up a major mystery in physics. Axions are a perfect example of how new particles can solve old problems. They show how creative thinking leads to big breakthroughs. The search for axions is on, and the stakes are cosmic. Could these tiny particles be the key to understanding the universe? Let's see why axions are more than just a neat solution. They might be the answer to another cosmic mystery, dark matter. If axions exist, they'd be incredibly light, billions of times lighter than electrons, and interact so weakly, they'd pass right through you. This makes them nearly impossible to detect, like tiny ghosts. But these properties make axions a top candidate for dark matter, the invisible stuff making up most of the universe's mass. We know dark matter exists because of its gravitational pull, but we don't know what it's made of. Axions fit the bill perfectly. To find them, scientists use clever experiments called axion haloscopes, trying to convert axions into detectable photons. The ADMX experiment uses strong magnets and supercooled cavities to catch the faintest signals. It's like tuning a radio to a station you're not sure exists. Discovering axions would be a double win, solving the strong CP problem and revealing the nature of dark matter. It would revolutionize our understanding of the cosmos. The hunt for axions is a patient, high-stakes game. Scientists are dedicated, using cutting-edge technology to chase these elusive particles. If found, axions could change everything we know about the universe. The search continues, with hope and excitement. Sometimes the smallest particles hold the biggest secrets. Will axions finally reveal themselves? The universe is waiting. We've met muons, the heavyweights with magnetic mysteries, tachyons, the faster-than-light phantoms, and axions, the ghostly solvers of cosmic puzzles. Why do these strange particles matter? Because they help us understand the fabric of reality. Studying them pushes the boundaries of knowledge and leads to breakthroughs we can't yet imagine. Muons already help us scan pyramids and volcanoes and might reveal new physics. Tachyons, even as theoretical oddities, force us to question our deepest assumptions. Axions could explain dark matter shaping galaxies and the universe itself. Each particle, real or hypothetical, adds a piece to the cosmic puzzle. Their stories are about curiosity, discovery, and our place in the universe. The pursuit of weird particles is an investment in our future understanding. Every new discovery opens a window onto how nature works. The universe is vast, complex, and full of surprises. There's always more to learn, more to explore. Keep asking questions and stay curious. The next weird particle could change everything we know. Science is a never-ending adventure. Thanks for joining this journey into the weirdest corners of physics. Until next time, keep exploring, keep